What's up, guys? We are going to continue working on our word problems, and today we're going to be focusing on work word problems. It says, a work word problem involves situations with two or more people working together, such as to paint a house, dig a hole, etc. Now, before we jump in this, I just want to review some things that we've been working on. First, we have distance equals rate times time. This has been the focus of everything that we've been doing these past few days, and it's going to continue being the focus, except we're going to change something. This equation is written in terms of distance. What I want to do is change it around so that it's written in terms of the rate. And that's going to be the difference between the work word problems versus distance and the distance problems as well as the mixture problems. Is I'm going to switch this around and we're going to isolate our r. So in order to do that, I divide both sides by t. And I'm left with r equals distance divided by time. Okay, distance divided by time. This is going to be kind of our parent formula that we're going to use on these work word problems. This will make more sense in just a second. But first, some of you love math. Some of you love your friends. But you will never love anything as much as this girl loves her fish. Isn't that adorable? All right, so basic work problem. Here's a very, very basic one. It says, suppose one painter can paint the entire house in 12 hours, and the second painter takes 8 hours. How long would it take the two painters to paint the house if they're working together? So we have painter 1, and we have painter 2. Now again, if you recall, I said everything we're going to be focusing on is going to be based upon this, where we have a rate, and rate is the distance divided by the amount of time, which makes sense. You think about like driving a car, it's miles, the distance, per, the division part, hour, miles per hour. So in this one it says, suppose one painter can paint the entire house in 12 hours. Well, then we'd say their rate is one house per 12 hours. That's their rate right there. So 1 over 12. And then we'd say painter 2 can do one house in 8 hours. Now, anytime I have rates, now you combine or you add rates. Think about this. On those other problems that we were looking at with the distance problems, if you were in a boat going down a stream and you are paddling along in the boat going 2 miles per hour and the stream is moving 3 miles per hour and you're going with it, then you're going a total of 5 miles per hour. Well, how do you know that? Well, you just add the rates. So we're going to be doing that exact same thing on this, and we're going to fill in the information that we have on this. So the first thing I know is that the rate is going to be this plus this. I combine rates. So I have 1/12 plus 1/8, and that's going to equal my distance. Now, it's not a technical distance, but it's an amount. Now, what do I want to know? I want to know two painters to paint the house together. So the distance, or what I'm trying to get finished, is going to be one house. And I want to know how long it would take the two of them together. This is kind of the basic setup of your formula right here. All right, so first thing that I would do is go ahead and add these two values. So I would have 1/12 plus 8 is 5/24 equals 1 over t. And then now I have a proportion that I'm going to solve. So it's cross multiply. So cross products are equivalent. So this times this, 5t, is equal to this times this. Then I divide by 5. And I get that t equals 4.8 hours. So most of the problems that we're going to be working on are going to set up like this, where I have the rates. And if I'm adding rates, it adds together like this. Is going to equal how many things I'm trying to get finished. In this case, it was one house, divided by the amount of time, which in this case was an unknown value. And then I solved that equation. So again, I added my fractions, and then I used cross products are equivalent to solve the rest. So that's the basic gist of how we're going to be doing those. Let's take a look at another one. It says, Will can finish the job in 3 hours. When working at the same time with Jacob, they could finish the job in 2 hours. How long does it take for Jacob to finish the job if he worked alone? So again, I'm going to be setting it up into rate equals distance divided by time. Okay, so Will can finish the job in 3 hours. So here's Will. Will can do it in 3 hours. Jacob, I don't know. All right, so Jacob, I'm going to put 1 over. He could do one house in the amount of time that he could do. I don't know what it is. So I'm going to call it J. Equals, it says they could finish the job, so they could do one job in 2 hours. All right, so here is my rate. So Will plus Jacob is the rate equals the distance of one job in the amount of time, which is 2 hours. This variable right here tells me how long Jacob takes to finish the job. All right, so to do this one, I would subtract 1/3 from both sides. And I end up getting, I'm going to come over here so I have space. I have 1 over J equals 1 over 6. So J, 6 times 1 divided by 1, or you could do what's called flipping the equation. If 1 over J equals 1 over 6, then J must equal 6. So Jacob could do the job in 6 hours. These really are not real difficult. The most difficult thing about them is going to be the setup, and you got to make sure that you get the setup in. Let's take a look at another one. This one's going to be pretty challenging. I just want you to bear with me. You're not going to see this kind on a checkpoint or anything, but it's not an impossible thing to look at. So again, we're going to be starting with this whole idea of rate equals distance divided by time. It says painters Peyton and Chelsea can paint a wall in 10 hours when working together. So it's one wall in 10 hours. That's my D over T right there. It says Chelsea works twice as fast as Peyton. Okay, so Chelsea's speed is twice as fast as Peyton. So I'm going to have to think about that a little bit. So first of all, let's start out with what Chelsea could do. Chelsea could paint the one house in Chelsea's speed. I don't know what that is. It's an unknown amount of time. But I know that whatever that amount of time that Chelsea does, if I double it, that's Peyton's time. In other words, if Chelsea can paint it in 5 hours, then Peyton's going to do it in 10 hours. If Chelsea can do it in 3 hours, Peyton will do it in 6 hours. So how am I getting these numbers? Well, for Peyton, I'm taking this C. She could do 1 and doubling the C. So 1 equals 2C. So here are my two rates for my problem. So I have 1 over C plus 1 over 2C. Now this makes it a little bit weird to combine these things. I'm going to show you something very, very quickly. But in order to do this, to add these fractions, because I got to get these C's together. To add these fractions, I multiply. I'm going to multiply these two things by whatever the other is. In other words, I'm going to have 2C times C. Hold on, just a moment. So in order to think about adding these things together, what I want you to think about is if I were adding, say, 1/2 plus 1/4. Well, because these aren't the same, I can't really add those. I got to do something. So I can multiply this one right here, both of these by 2. And what I'd have would be 2/4 plus the 1/4. And I could go ahead and add those because I have like denominators. Well, this is going to work very, very similarly. I'm going to multiply this by 2 and this by 2, and it doesn't change that fraction. What I end up getting is 2 over 2C plus 1 over 2C. And I'm just going to tell you right now, this is not the only way to do this problem. This is just how I would set it up. So here, like denominators, I go ahead and add these. Let me give myself some space here. Actually, I don't want to erase that. Hold on. Let's put that C back. Yeah, so C still equals that. I'll come over here and crunch it in. Okay, so 2 plus 1 is going to be 3 over 2C equals 1 over 10. And here I would do the same thing. Cross products are equivalent. So I get 2 times 1, which is 2C, equals 3 times 10, which is 30. Divide both sides by 2. And C equals 15. If Chelsea can paint it in 15 hours, Peyton takes twice as long. So Peyton must be able to do it in 30 hours. Now again, you don't have one this complicated, although I don't think it's impossible. This part's probably a little bit weird for you. We will be talking about this stuff later this year. But the whole thing, if you're able to understand this and set it up using that, where you add the rates and it's going to equal the distance divided by the time, you should be okay on these. I believe that's it for today, just a few examples. Yep, that's it. So make sure you've taken good notes, and I'll see you in class.